Hello everyone. Today I'll be going through the math methods 1 and 2 mini test. So all the answers are on the screen. All right, cool. Let's start going over them. So first part, we have to find the rule of each graph. So by noticing how that at x equals -1, the graph has a turning point, and so it's a turning point and an intercept. That's why we know that the graph will contain a bracket of x plus 1 squared. So if you're not familiar with this concept, it's basically that when at a graph where it's an intercept and a turning point, let's say this point is a, then it must be x plus a squared, or to the power of 4, to the power of 5, etc. So it will be, I mean, not to the power of 5, sorry, it will be x to the even power. The reason for that is that when we take the derivative, we would all still keep the things as so we get, let's just take it, let's just sum it to 2 as the context, right? So because this is an intercept and a turning point, if we take the derivative, we'll get 2 of x plus a. So here, it shows us that at x equals to -a, it equals to 0 because this is a derivative function, indicating that this is a turning point, which matches the case. And with this being in this form, it will also, this part, which is the original function, will tell us that a is also an intercept. So it has to be in the form of, well, x plus a to the power of 2 or 4 or 6 or whatever. It has to be even power, because if it's an odd power, then instead of being it like this, it would go down like that. Anyway, let's go back to the question. So we know that since the graph has an intercept and a turning point at x equals -1, a part of it must be x plus 1 squared. And since the graph has another intercept at x equals to 3, then it will be x minus 3 something, right? So the only thing we don't know now is the dilution factor at the front. So the graph, we'll get to this part of the graph being a times x plus 1 squared times x minus 3. And a is the dilution factor we don't know. To get the dilution factor, we look at the intercept here, which is 0, 6. So we're subbing x equals to 0 and y equals to 6. And we get a equals to -2. And therefore, we get the graph is equal to y equals to -2 times x plus 1 squared times x minus 3. All right, for the next graph, it's kind of the same logic here. At each intercept points, I kind of marked out what we have to have. So here we will have x plus 2, here x plus 1, here x minus 1, and here x minus 3. We combine them all together, and we don't know what a is. We sub in 0, 6 again. We will get 6 equals to a times all this. This is just where x equals to 0. And then we get a equals 1, therefore y is just equal to this function here. And keep in mind, we do not need to expand this, but writing it in this form is perfectly fine. All right, the next part is to find the inverse function of the following. To do that, we just swap x and y. So this is f of x equals to this. So we swap x to f of x and x to, well, y, but in this case, you can write as f of x if you want. So we swap them around and we rearrange to make y the subject. So eventually we'll get y equals to 2 plus cube root of x minus 2. And just for the final step, just replace y to f inverse of x. So we get f inverse of x equals to 2 plus cube root of x minus 2. So all the working out is shown here. And for this type of question, so for the second one, recall that for a graph to have an inverse function, it must be a one-to-one function. But what we have here is actually parabola. So if I actually try to sketch this, it will look something like this. Right, so this will be its turning point at 1 and 3. So, but this function isn't a one-to-one, because if we do a horizontal line test, we'll get, well, 2 values. So therefore, it gives us a limited domain of 1 to infinity. So essentially, instead of being the function before, we will just have this edge of this function, and that will be a one-to-one function. And that's why the inverse function of this graph exists. Then it will be the same logic. We will rearrange to make x the subject, so x equals to y minus 1 squared plus 3. This is an equal sign. Let me make it more clearer. X minus 3 is equal to y minus 1 squared. So keep in mind, normally here would be plus minus square root of x minus 3, because we're taking square roots here. But the domain tells us x has to be, the domain tells us that basically y has to be bigger than 0, right? So if we have a negative here, then y would be less than 0. Therefore, we can assume it's the positive end. Then we get square root of x minus 3 is equal to y minus 1, rearrange, and don't forget to swap y to f inverse of x. for your final step. So we get f inverse of x equal to 1 plus square root of x minus 3. For the final two questions, I think the best way to solve them is graphically. So for the first one, we can put it into intercept form, x minus 3, x plus 1 less than 0. We graph it, we kind of see that. So this is -1 here, this is 3 here. Between the intercept, the graph is less than 0. Therefore, x is relevant from -1 to 3 exclusive. And that will be the answer to this question. For this one, again, same logic, we just graph the graph. It will look something like this. And then we're looking for the place where y is greater than 0, which is everything beyond this point. And this point has a coordinate 1, 0. Therefore, x is just greater than 1 for the final question here. Yep, so that's everything for this worksheet. If you guys have any other questions, please just let me know or come to the Math Study Hub where I'll also be there to answer questions.